So a little disclaimer before we get into this. This is about caliber debates, not platforms, not jacketed hollow point versus full metal jacket versus extreme penetrator, and again, not about platforms. We all have our favorite cartridges, and we've seen a bunch of YouTube videos, everyone arguing why theirs is the best. And we talk about things like speed and barrier penetrators, knowing what's beyond your target, over penetration, 12 to 16 inches of penetration, wound cavities, 1-2 world wars, the Lord's caliber. We all argue why we have a favorite caliber. And what I mean by putting this debate to end is we're just going to look at the science of calibers that I'm listing that are close to the common ones, but not. So technically, these are not actual calibers, but they're pretty close. And if you're a fan of a certain caliber, you should be able to articulate why it's your favorite cartridge, why it's better than other cartridges, and around its speed and average weights. So when you look at these pictures here, you're going to be looking at non-existent calibers, but they're close to actual calibers. Now let's get into it. Right now, you are looking at a 217 grain projectile coming at you at 850 feet per second, delivering 348 foot-pounds of energy. The one below it is 628 grains, coming at you at 1,600 feet per second, delivering 3,569 foot-pounds of energy. Okay. And then you have 151 grains coming at you at 1,300 feet per second, delivering 566 foot-pounds of energy. So looking at the three of these, which one do you think is the best? Next one. We have a 51 grain traveling at 3,000 feet per second, delivering 1,018 foot-pounds of energy. So of course, we're going to obviously know that the more the weight, the bigger the projectile as well, because we always like to talk about size. Different sizes do different things. Third example here. So now we have 112 grains traveling at 1,100 feet per second, delivering 300 foot-pounds of energy. Now we have 172 grains traveling at 900 feet per second, delivering 309 foot-pounds of energy. Well, how's this? Wait a minute. Whoa. You made a mistake, kinetic energy, right? No, I did not. We also have a 172 grain projectile traveling at now 1,300 feet per second, delivering 645 foot-pounds of energy. Now, which one would be the best for what we like to argue? Penetration, over penetration, wound cavity, best caliber? Let me know. We are now at the next slide. We have a 37 grain, obviously smaller and much lighter, traveling at 1,100 feet per second, delivering 99 foot-pounds of energy. Again, I did not make a mistake. We have the exact same caliber, a 37 grain, now traveling at 1,500 feet per second, delivering 184 foot-pounds of energy. Interesting, huh? Last but not least, we have a 440 grain, traveling at 1,600 feet per second. We know it ain't 10 millimeter or 45, delivering 2,500 foot-pounds of energy. So those are the facts. These are what these projectiles cartridges do. Again, it's the caliber debate. Take that word cartridge out of there. Everyone argues their favorite caliber. Okay, why? We just did a whole bunch of mock calibers that are close to the real calibers, and we showed you what they do. They travel at a certain amount of speed and deliver a certain amount of energy. So I'm interested, maybe just leave a comment. Which one would you pick out of all of these to say is the best caliber? But you also need to articulate why. There's no platforms, there's no dots, there's no optics. So that's why I say this should end the caliber debate. Right now, you just have numbers in front of you of what these calibers do. Just a different way of looking at it. But are we really know why our cartridge, our, never mind the word cartridge, why our caliber is the best versus another one? Or are we really just a bunch of fanboys that really just have a preference? Thanks for watching. Let me know your thoughts.